Hey everyone! So today, we're going to decode some of those symbols in Trig that can look, a little intimidating. We're going to use this student's worksheet as our guide to figure out what on earth that little -1 next to sine actually means. And trust me, it is the key to solving a whole bunch of problems.
So think about this. You've probably spent tons of time using sine, cosine, and tangent to find the length of a side of a triangle, right? But what if the tables are turned? What if you already have the sides, but you need to find the angle? That's a whole different ballgame, and it's the exact problem these inverse functions were born to solve.
Honestly, the easiest way to wrap your head around this is to think of it like an undo button. It really is that simple. You know how the sine function takes an angle and spits out a ratio? Well, the inverse sine function does the exact opposite. You feed it the ratio and it gives you back the angle that made it. It's just working in reverse. Okay, so let's get just a little more formal with that undo idea. The inverse sine, the one written with that little -1, is just a function where you give it a value, x, and it tells you the angle, y. That's why these two expressions you see here are basically the same thing. They're just two different ways of writing the exact same relationship. And hey, don't just take my word for it. This isn't some random rule I made up. It's the absolute foundation for this whole topic. You can see it right here on our source worksheet, boxed up right at the top of the page. Seriously, this relationship is the key to everything else we're going to do.
Now, a quick heads up, because math just loves to have two names for the same thing, you're going to see sine -1x written another way, as arc sine x. Don't let it throw you. Arc sine, arc cos, arc tan, they all mean the exact same thing. Find me the angle. The arc part is just referring to the arc on a unit circle.
Okay, so here's where things get a little tricky. The big question. If I ask you, what angle has a sine of 1/2? Well, 30 degrees works. But so does 150 degrees, and you could go around the circle again and get 390 degrees. They all work. So if a function is only supposed to give one single output, how in the world do we decide which one is the correct answer?
And our worksheet, believe it or not, gives us the answer not with another equation, but with a picture. The entire solution to this puzzle is hiding right here in these simple-looking shaded circles. They might not look like much, but they are absolutely essential for making these functions work properly.
So what's the deal with those diagrams? Well, it all comes down to a core rule in math. For something to be a function, every input gets exactly one output. But the sine wave repeats forever, right? So we have to basically agree to limit or restrict our answers. We're drawing a line in the sand and saying, okay, out of all the infinite possible angles, we're only going to accept answers that fall in this specific little slice. And here they are. These are those specific slices laid out as the official rules. Each inverse function has its own little territory. We're mostly focused on arcsin today, and for that one, our answer must live somewhere between -π/2 and +π/2. No exceptions. As you can see, arc cos and arc tan have their own unique windows too. These are the rules of the game.
All right, enough theory. Let's actually put this to work. It's time to solve the first problem from our source sheet. We're asked to find the exact value of the inverse sine of the square root of 3/2. So, first thing we do is translate that from math speak into a plain question. What we're really asking is, what angle has a sine that's equal to the square root of 3/2? Now, if you're thinking about your unit circle, which you should be, two answers probably pop into your head right away: π/3 and 2π/3.
And that's exactly the pickle we're in. For our problem, we have two candidates right off the bat, π/3 and 2π/3. This perfectly shows that ambiguity we were just talking about. We've got two initial possibilities, but a function can only give one answer. But now it's time to use our new superpower, the restricted range. Remember that rule? For arc sine, the answer has to fall between -π/2 and +π/2. So let's check our two options. Is 2π/3 inside that required range? Nope, it's too big, so we have to toss it out. And what does that leave us with? Just π/3. Boom, that is our one unique correct answer. Cool. So that's how we handle the positive values. Now let's see what happens with a negative input. We're moving on to problem 1b, arc sine of -1. The question is exactly the same, just a different number. We're looking for an angle whose sine is -1. And the answer, as we can see right here on the worksheet, is -π/2. So let's check it against our rule. Is -π/2 inside our required range? Yes, it is. It's right on the boundary. But since the rule includes the endpoints, it is a perfect, valid answer.
All right, now for part C. This one looks super simple, but I promise you, it's a bit of a trick question. We need to find the inverse sine of -3.
And this is brilliant because it illustrates a whole new rule. Look at what the student wrote and circled. Undefined. It's not a number, it's not an angle. It means the function just can't. It can't give an answer.
So why? How can there just be no answer? We've talked a lot about the rules for the output, the angle. But does this mean there are also rules about the input, about what you're allowed to plug in to begin with?
Oh, you bet there are. And it makes perfect sense. For a regular sine function, the answer that comes out is always trapped between -1 and 1. It can't ever be bigger or smaller than that. So when we use the inverse function, which just swaps the inputs and outputs, that rule comes along for the ride. It means the new input has to be between -1 and 1. And -3? It's way outside that zone. It's impossible. No angle in the universe has a sine of -3.
And you know what's so great? Our student knew it. Look at this fantastic little note they wrote to themselves right here. Recall, -1 is less than or equal to x is less than or equal to 1. They remembered that crucial input restriction, and that is exactly why the answer is and has to be undefined.
So, let's just do a quick recap. What are the big things to remember? First, inverse trig functions are your tool for finding a missing angle. Second, don't get spooked by arcsine. It's just another name for the same thing. Third, their real power comes from those strict, restricted ranges. That's what makes them work. And finally, don't forget the input rules. For arcsine and arccos, you can only feed them numbers between -1 and 1.
And that kind of leaves us with one final thought. We called this an undo function. What other mathematical operations do you use all the time that are really just undoing something else? Think about it. Thanks for digging into this with me.